Good morning, boys. Today we're looking at solving quadratic problems. Now, last lesson we revised quadratic equations and we're looking at how to solve them via factorizations. Next lesson, of course, we'll look at the other methods like completing the square, quadratic formula, and all those other bits and pieces. But today we're actually looking at the problem solving, so that working mathematical type of questions. Again, like the simultaneous equations, these are generally our worded questions. We have to come up with the equation from the information given to us. There are usually some pretty straightforward questions that we get. I'm going to show you two of those, and then obviously you do get some more challenging ones depending on what the numbers are. So the first one is a really kind of usual sort of question. A rectangle has an area of 24 square meters. Its length is 5 meters more than its breadth. What are the dimensions? So first of all, what you'll notice that there is no diagram. And I really think that is one of the most important aspects of this question, is to draw down a diagram so it gives you a better picture about what's going on. Now, we know that the area equals 24 meters squared. We know that its length is 5 meters more than its breadth. So let's say the breadth is x meters. Therefore, the length would be x plus 5 meters. Okay, and so that's really important because now I've got like a starting point, right? So I want to come up with some type of equation linking it together. Now, how do you find the area of a rectangle? Well, we multiply the two sides together. So that means in this question, I'm just going to change my color here, that when I multiply x and x plus 5 together, the answer is going to be 24. Now, that has been factorized. The problem is with this question, we can't solve it in this format because the answer equals 24. You know, if I try to solve it, you could be doing 3 times 8 is 24, 8 times 3 is 24, 6 times 4 is 24, 4 times 6 is 24, 24 on 1. There are an infinite amount of possibilities when you start looking at decimal places. It's just too hard. So what we want to do is actually expand these brackets out as we're doing. And like we said last lesson, if it doesn't equal 0, let's push it into making it equal 0. So I'm going to subtract that 24 to that left-hand side. So now that it equals 0, I can try and factorize it to come up with a null factor theorem style of question. Now, if I look at the factorization for this, again, I'm thinking about numbers. 24 is my product, so things like 8 and 3 and 6 and 4. Which of those two could make 5? Well, 6 and 4 can't, but 8 and 3 can make 5. 8 subtract 5 makes 3. So x plus 8. So 8 subtract 3. And that works out nicely because it makes a negative 24, and it also, when it adds together, it makes positive 5. Again, if you need your scaffolding, when we're doing our product in our sum and putting in the negative 24 and the positive 5 and then doing your 8 minus 3, if you need to do that stuff, by all means do it, but at this level, you should be pushing yourself to do it up here. Okay, now I've got that. That solution becomes pretty straightforward. X equals minus 8 and x equals positive 3. Now, it wants dimensions, and I'm hoping you kind of see something that's actually happening here, because I've got two possible solutions. However, only one of those is correct. So I often say this: x must be greater than 0, because we're talking about a measurement, a length. You can't have a rectangle with a negative length or even a 0 length, because it wouldn't be a rectangle. It must be greater than 0. Therefore, x can only equal 3, and that's my initial solution. And I find that's really important, okay? Now, the other thing I want you to then do is I want you to answer the questions, ask for the dimensions. That means I go back and look at the lengths. So I've got 3 meters by 3 plus 5 makes 8. I have 8 meters, and that is the dimensions for my rectangle. Okay, and of course 3 times 8 makes 24. I'm good to go. Okay, so again, I hope that made sense. Create that equation, make sure it equals 0, factorize it if you can, and then solve it. make sure because it's an applied question, you make sure that both solutions are accurate, or whichever one might be accurate, and omit the other one. But don't just let the other one out. State why you're leaving it out, or why you're just taking one solution, and then answer your question. Okay, another common question, if you want to pause it and have a crack at it, you're most welcome to. This is a Pythagoras question. There's no trigonometry because there's no degrees in there. It's all three sides. So let's start by applying a bit of Pythag. X squared plus x plus 2 squared equals 10 squared. That's coming from our a squared plus b squared equals c squared. I'm now going to expand those brackets out. X squared plus 4x plus 4 equals 100. Now, let's make sure, of course, that you should be able to expand those quickly using our product rule, our binomial product rule, or perfect square rule, should I say. Now, I'm going to simplify. X squared plus x squared is 2x squared plus 4x. I'm going to subtract the 100 across to make minus 96 equals 0. Now, this is a nice question, right? Because now I've got this. It equals 0, so it might be a null factor theorem if I can factorize. Because I'm doing it, it should be able to be factorized. But I like this because at the moment, this is a non-monic, and we know that non-monics can be a bit more challenging. However, if I take the 2 out as such, like that, and I now divide it across by 2, we're actually left with x squared plus 2x minus 48 equals 0. Okay. Now, of course, you actually don't need to write that last step. You can just leave the 2 at the front, and that's fine. Because now I've got a quadratic which I can hopefully factorize. Again, if you need to do your product and sums, I'm hoping that you probably don't, but negative 48 and 2, we're looking for two numbers, 6 and 8. 6 8's 48, and 6 and 8 can make 2. How can that happen? Well, 8 minus 6, that makes 2. That makes negative 48. So very quickly, I've come out with this nice solution of x plus 8, x minus 6 equals 0. If you want to have the 2 at the front and go from there, by all means, it's okay, it's fine. Because now I can clearly see that x equals minus 8, and I can see that x equals positive 6. Now, like that last question, there is a side that just has x. That means that x can't equal negative 8 because we can't have a negative length. Same for the top one. We can't have negative 6 on top. So we must say x must be greater than 0, therefore x equals 6. Okay, and my job's done, I found x. But of course, I go back to the question. Did the question ask me to find x? No, it didn't. It said to find perimeter. Okay, so therefore all I'm going to do now is say 6 plus 8 plus 10, that equals 24 meters, or what units, let's say, and I have my answer. Now that was a bell, so good timing again. Have a wonderful day. Go through the questions today. Any problems, message me on Canvas. Enjoy.